Imagine drifting through deep space. You're surrounded by stars, but moving silently through the darkness is a threat you cannot even see. This is a black hole. It sits motionless in the vacuum, yet generates enough gravitational force to consume entire star systems. This raises a terrifying question. If you were to slip too close and fall into one, what would actually happen to your body? To answer that, we have to look past the limits of normal physics and see what happens when human biology meets the absolute extremes of the universe. This diagram shows a massive star in its stable state. For millions of years, it balances outward thermal energy against the inward crush of gravity. But when it exhausts its fuel, internal pressure vanishes. Gravity immediately wins, crushing the mass inward with unimaginable force. In mere seconds, an object significantly larger than our sun is compressed into a space smaller than a modern city. This extreme density creates a localized gravitational pull so intense that the velocity required to escape it is faster than the speed of light. A black hole represents the final physical victory of gravity over matter, creating a region of space where any descent is strictly a one-way trip. From a safe distance, the approach appears deceptively calm. The true danger remains entirely invisible. This diagram illustrates gravitational lensing. The extreme mass of the black hole warps the fabric of space-time, forcing the light of background stars to bend unnaturally as it passes the anomaly. Because space and time are physically linked, this curvature also creates time dilation. The deeper you move into the gravity well, the slower time passes for you relative to the rest of the universe. An outside observer would watch you slow down until you appear to freeze near the edge forever. But for you, time feels normal. You might experience mere minutes while years pass across the galaxy. Proximity to a black hole severs your connection to objective reality, warping both vision and time long before you feel any physical harm. Your fall eventually reaches the event horizon. This is the strict boundary where the velocity needed to escape finally exceeds the speed of light. Crossing this threshold brings total isolation. No light, radio signal, or information can ever be transmitted back to the outside world. At this point, human agency vanishes. You are no longer a cosmic observer, but a permanent prisoner of the anomaly. Past the horizon, as you move towards the center, you encounter immense tidal forces. As shown in this diagram, the gravitational gradient is so steep that the pull on your feet is vastly stronger than the pull on your head. This discrepancy results in a violent, continuous stretching of the human form, known as spaghettification. Flesh and bone cannot withstand this tension. The body is systematically torn apart, atom by atom. In this environment, gravity acts as a brutal mechanical shredder, dismantling physical matter at its most basic level. At the very center lies the singularity, where all consumed mass is infinitely compressed into zero volume. At this exact mathematical point, the known laws of physics, space, and time cease to function. Scientific theories clash here. Some suggest total, eternal destruction, while others theorize that these points might serve as bridges to other universes. The core of a black hole remains an impenetrable blind spot in our map of the universe, a region where the internal logic of the cosmos stays locked away behind a wall of gravity. Millions of these objects exist silently in our galaxy, exerting their influence over the stars around them. They highlight the fragility of human life when compared to the vast, cold, and violent mechanics of the wider universe. Black holes are the ultimate reminder of our smallness in a deeply strange cosmos. Subscribe as we explore more of space's greatest mysteries.